folks, welcome back. This is Joel, and in this video we'll talk a little bit about IPv6 transition technologies, right? Let's go to the config guide, which we'll be looking into for configuring this, right? So it's a bit of an old config guide, 15.2. Probably the release is not even supported anymore, but our IOL routers basically support this release. I'm just using the configs from here. But the logic and the fundamentals which we're going to look here, right, are going to remain valid even to this day, irrespective of which operating system you're going to use. Okay, so just the problem statement, right? What do we have here? So you see on the left hand side we have a IPv6 network, right? And on the right hand side also we have a IPv6 network. And in the center you have a IPv4 transport, right? Basically this is IPv4 only network in the center. It doesn't support v6, and that's kind of the situation even today, right? There are so many networks or so many layers in the middle which really don't support v6. So how would you kind of get both of these IPv6 islands to talk to each other, right? Big question. So that's where this tunneling protocols come into play. And again, I mean, tunneling is not just the only option. You can do it using much amazing technologies like MPLS and so on, which we will probably look into later. But for now, we'll look into some of the valid technologies, which is using tunneling, right? So again, this document has everything what we'll basically be using today, right? It has all the configurations, explanations, different types, what kind of tunnels you should use, why should you use them, advantages, disadvantages. So you're free to feel free to kind of come here and check this out. But in our video, we'll basically be concentrating on the configs, right? So just a minute to spend here on the topology which we have. What do we have here? Okay, so we've got two customers. Let's call this as, say, I don't know, maybe red, and the right hand side is the green customer. So we've got like two customers, and in the center we have that IPv4 only network. This is only IPv4, right? Doesn't support v6. So starting from R1, R2, R3, R4 and R5, right? These 5 routers, they are only IPv4, doesn't support v6. So, and then we'll probably not even look at the green side for now, right? For the tunneling, what are the technologies which we are going to look into, starting with GRE. Next would be IPv6 IP, right? You'll get to know what is that, but the other one is 624, and the last one probably would be ISATAP. There are a lot of, again, there are a lot of other options within these tunnels, right? We'll just try to see how much we can do in a quick short video, right? All right. So, but what is the basic fundamentals? So the basic idea here is that we know for sure that this customer supports IPv6. That is, in his network, say on switch 1 and on switch 2, he has IPv6 enabled. But he also knows that in the middle, we don't have IPv6, right? So all these technologies are basically tunneling technologies, where what we do is let's say in this case, we create a tunnel of this sort. We create a tunnel starting from R1 to R4, right? And that tunnel will be IPv4 tunnel, regular tunnel, right? You know the tunnel, right? What is a tunnel generally? You generally have some kind of payload, right? And you append an extra header, right? And this will be that IPv4 source and the IPv4 destination, right? So this is that extra header, this is the payload, and you put this extra header so that the packet will pass through the transport network or the IPv4 only network, right? So that's what we are aiming for, that's what we want to achieve, and we are basically going to do that using this various kind of tunnels. There are obviously some advantages, disadvantages, and there are difference, and we'll probably explore that along with some packet walks and so on as we configure them. Okay, let's go and hide that. Let's go to our configs, right? So let's start with what? GRE, guys. Let's start with GRE. So so when we start talking with GRE, we'll just, like I said, we're going to concentrate only on the red customer. So we'll do the tunnel between R1 and R4 for GRE, right? So let's come here. Okay, so let's get to the screen here. Okay, so we are on R1, that's fine. What do we have right now? Like I told you, let's look at the underlay, right, or the IPv4 part of it. So show IPv4 route. Sorry. Okay, so this is basically my underlay, or basically the IGP which I was talking about, the IPv4 only network, right? So we have a OSPF running here in this, yellow box over here. I'm not going to show you how to do that. It's basically nothing but going and enabling OSPF on those interfaces, right? Cool. So we have those networks visible down there. And the other thing is, let's also look at the IPv6. So on the IPv6 side, you can see, and probably let's look at the show CDP neighbors as well. You can see this R1 is connected to switch 1 and switch 3 on Ethernet 0/00/1, and only on those interfaces we have V6, right? On 0/2 we don't have V6 because, like I said, it's IPv4 only. Okay, so let's go about configuring our tunnel now. I think we are ready, right? So the tunnel. So let's start with tunnel 0. Let's keep on looking at the diagram. So we are on R1. We are configuring the tunnel. Right, we'll enable on the tunnel, let's enable some routing protocol, right? So we'll enable, say, EIGRP. Any protocol you can pick. I'm going to use EIGRP, right? This protocol, this routing is only for the IPv6 part. So that's why I'm saying IPv6 EIGRP 100. Okay, what else? So what will be the source interface for this tunnel? Okay, or maybe before going to that, let's also see if we have enabled IPv6 on these interfaces. I don't think we have. We can quickly check. To show run interface Ethernet 0/0. Do we have it? No. See, we don't have it. So let's enable that. So let's get to interface Ethernet 0/0. Right. We are not going to do anything on the switch 3 side because that belongs to the green customer. We are just concentrating only on the red customer now. Right. So on this interface, let's enable the same EIGRP which we enabled above. So I'm going to say IPv6 EIGRP 100. Okay, and you also know that for EIGRP to be enabled, you need to do it on the global routing as well. So we need to enable IPv6 router EIGRP 100. Okay, so that basically does the trick. So what we have done as of now, we have just enabled the tunnel. We have enabled the tunnel and we have gone and enabled EIGRP on it. And we have also enabled EIGRP on the switch side, that's switch 1 side. Okay. So let's quickly do the exact same thing. Let's do this step by step, right? So let's do the same thing here. I'm going to say tunnel 0 and IPv6 EIGRP 100. And what is let's do show CDP neighbors here. Okay, it's going to be Ethernet 0/0, so that's going to be the interface here. And here also we are going to say IPv6 EIGRP 100 and then IPv6 router EIGRP 100. That's enabling EIGRP. Okay, looks good. Okay, so next part. Let's go to our switches. So what we did now, let's recap. Yeah, there we go. So what we did, we just enabled the EIGRP on router 1 and router 4, and we enabled the tunnel and we enabled the EIGRP on the switch side on both the sides, right? The next thing we will do is let's play around the switch 1 and switch 2, right? Let's go to switch 1 and there we go. Show CDP neighbors. Okay, my bad. CDP neighbors, okay, there we go. Oh, so many mistakes, my bad. Okay, so Ethernet 0/0 is our interface, right? So that's the interface which is connecting to R1, and we should also have some IPv6 loopbacks here. Show IPv6 interface brief. Okay, there you go. We have two loopbacks, loopback 0 and loopback 1. So it is 100::7 on switch 1 and it will be 100::8 on switch 2. Okay, so what we'll do is let's enable, let's go to loopback 0 and let's enable the same thing, IPv6 EIGRP 100. And same thing on interface loopback 1, IPv6 EIGRP 100. Okay, looks good. What else do we need to do on this one? We also have the SVI, right? That's how this is set up. Okay, so maybe if you want a little bit of explanation, what we have done is here, because this is a switch, right? We can't really have a L3 interface on that switch. So that's why what we have is, let me grab the pen. Okay, so yeah, so what we have is basically we have a SVI set up on this one. We also have a SVI on this one. right? And we have enabled this particular interface in that particular VLAN, right? Actually, let me show it to you. So on the switch 1, if you go to switch 1, we have something like I think it's basically we can do something like show VLAN brief, right? There you go. So we've got this one, right? VLAN 71, right? Because it is connecting switch to the router 1, it's basically 71, and you know, you have the Ethernet 0/0 which is in that VLAN, right? And as a result, we also have the SVI. What is SVI? Show run interface VLAN 71, right? So that's my SVI, right? So I need to basically go and enable the EIGRP on this one, right? Because we want the whole connectivity. We want the complete connectivity from switch 1 to switch 2. So all the networks which are there on switch 1, right? Basically the loopback 0, loopback 1, and the VLAN which we have, right? We'll have to enable IPv6 EIGRP, so that once you enable EIGRP on everything, it will be able to establish EIGRP with the R1. Similarly, we'll have to do the same thing on switch 2 here, so that, you know, you will have like end-to-end EIGRP running, right? So let's do that. So we'll go to interface VLAN 71 and we'll say IPv6 EIGRP 100. Okay, and the regular stuff, we will have to enable this router EIGRP 100. Alright, so that's done. So yeah, there you go, right? Now you have the neighborship come up. So we have the neighborship coming up between switch 1 and R1. Okay, same thing should be done here, but here if you see show VLAN brief, the VLAN is going to be making a lot of mistakes today. Show VLAN brief. Okay, there you go. The VLAN is 84. So let's do this. So let's enable it on loopback 0, IPv6 EIGRP 100. Let's do it on loopback 1, right? The same thing. And let's do it on interface VLAN, which one? 84. So let's do it on 84. There you go. And then enable it globally, which is IPv6 router EIGRP. Yeah, correct. EIGRP 100. Okay. So by doing this, now the neighborship with the between switch 2 and the router 4 should come up. Okay. So that's good. We have done that stuff. Let's go and check what routes do we have. So if you come to R1 and if you do something like do show IPv6 route, and if I'm interested only with say EIGRP, right, that's what we have. We have two routes, right? So we've got the route, the loopback 0 and the loopback 1 of my switch 1, right? The same thing will be visible if I go to my R4, right? And okay, that. So if I do right, the same thing, right? The only difference is on R4 we have the loopback of switch 2 and loopback 0 and 1 of switch 2. Okay, so all of that is set up, right? Come back to the diagram. We have set up the EIGRP over here on the top. We have set up the EIGRP here on the bottom, right? So all of that is good. What is the next step? The next step is obviously going to the tunnel. So we have on this R1, we have just created the tunnel, but we don't have anything on the tunnel. So let's come back here. I'm going to say tunnel 0. And in this tunnel, let's put an IP address for this tunnel, right? Let's put an IPv6 address. I'm going to say IPv6 address 2001 DB8, right? I'm just using a 2001 address from our network, right? DB8, say 100 colon 200 colon 1 because it is R1, right? /64. Then what will be the tunnel source address? Every time you create a tunnel, you need a tunnel source and the destination, which will be used for that encapsulation, right? So for the tunnel address, we have given a v6 address, but observe for the tunnel source address, we will use the loopback 0, which is nothing but IPv4 address, okay, which is 1.1.1, right? And the tunnel destination is going to be what? I want to create a tunnel to R4, so I'm going to say 4.4.4. Sweet, right? That's good. The same thing, let's copy this address because we'll have to create the other address on the other side, basically for the tunnel in the same network, right? So I'm going to say tunnel 0 and IPv6 address is going to be, the only difference is change this 1 to 4, okay? And what? The tunnel source is going to be what? Loopback 0, and the tunnel destination is going to be 1.1.1, Got it? Looks good. There you go. The adjacency has come up, guys. So we have the adjacency which came up over the tunnel, right? We established the EIGRP adjacency over the tunnel, right? So first we brought up the tunnel. The tunnel is a pure, basically a V4 tunnel. But over that V4 tunnel, now we are sending the IPv6 packets. As a result, the tunnel came up, and you can see the EIGRP neighborship came up over the tunnel, right? Isn't this good? So what I'll do quickly now is, let me take a minute to pause the video and grab the captures. Alright, so I've got the capture here. There you go. I'm going to pull it on the screen. So I'm basically capturing it at this place, right? Ethernet 0/2. So let's look at the captures. Let's look at probably the EIGRP packets. So let's pick a EIGRP packet. You can see here, if you pick a EIGRP packet, it is clearly showing us that the outer header is a V4 header, right? You can see the outer address, or the outer header basically has the tunnel source and tunnel destination. So it's a V4 tunnel, and inside that tunnel we are basically sending the GRE IPv6 packet, right? The GRE encapsulation is IPv6 encapsulation, and then inside that we have the IPv6 header, and then you have the EIGRP data in this case, right? It won't be EIGRP data always. If you're sending some other kind of data, say in our case, let's ping it. Let's do a ping. Let's see what happens. So sorry, did I open a new one? My bad. So let's come here on the switch, right? Let's ping the other side, which is switch 2. So when I do a ping, there you go, the ping is gone. And you can see the packet here. Though I'm pinging a V6 address, over the V4 network, you can see how it is going, right? You have the payload, which is the V6 ping, and then the inner header basically is a V6 header. Then you have the GRE encapsulation. This is just 4 bytes of data, right? The GRE encapsulation, GRE header basically. And then you have the outer IP header, which is basically the tunnel source and destination, right? So this is how it basically works, right? So what we really did was, without losing sleep, we were able to connect this R1 to R4 via a tunnel, and as a result, now we have complete connectivity via IPv6, right? From switch 1 to switch 2, or basically any network behind the switch 1 will be able to talk to any network behind switch 2 natively using IPv6 because of this whole tunneling concept which we introduced here. Alright, so for the second one, which is IPv6 IP, right? That's the second tunnel. Literally there is nothing which we have to do, right? So let me just get rid of that. Let's come here. Let's look at the current tunnel, right? Let's go to R1 and let's clear the screen a bit. Let's do show interface tunnel 0, right? As of now, if you see, the tunnel MTU, right, is 1476 bytes. That is, you can send so much amount of data. You can't send more than that, because if you send more than that, then the transport's MTU gets crossed, right? So you should limit your data, the payload, to only 1476. And the reason it is 1476 is because 4 bytes is basically used by the GRE header. I showed you that in the previous capture, right? I shouldn't have actually deleted the capture. So what I'm going to do is, now let's change this tunnel. So how do we do that? Just one command. So we'll go to the tunnel 0, right? We'll just say tunnel mode, right? I'll say IPv6 IP, right? There you go. So I changed it from GRE to IPv6 IP. I gotta do the same thing on the other side as well, otherwise there'll be a mismatch, right? So I'm already inside tunnel, so I'm gonna say IPv6 IP. Okay, so there you go. Now if I go back and check, right, let's check the same command which we checked here, which is show tunnel 0, show interface tunnel 0. Let's try that. And what happened? See the difference, right? It was 1476. Now we have 4 more extra bytes, right? So now IPv6 or the device is telling us that I can send more payload. I can send 4 more bytes of payload because we eliminated the GRE header. We no longer want the GRE header, right? So this is the second variant, which is exactly same as your GRE tunnels. It's just that we removed, or basically we removed the GRE is like the default mode, right? So we changed from the GRE mode to IPv6 IP mode, and when you change to this, that GRE header, the 4 bytes are removed, and everything will still work, right? Basically, if I go back to my switch 1 and do the ping, it will still work. There you go, right? It's just that those 4 bytes are removed. Okay, So whatever these two tunnels which we looked at just now, they are mainly point-to-point tunnels, right? Which means that when I create the tunnel, I literally need to provide, like if you look at the configuration of one of the tunnel here, do show run interface tunnel 0, right? So you literally need to mention what is the source and the destination. So this tunnel is just a point-to-point. It is if you want to create one more tunnel, you have to create one more point-to-point tunnel. Right now this tunnel is serving only R1, R4, right? That's why it is point-to-point. The next two tunnels which we are going to look at, 624 and the ISATAP, they are kind of like dynamic multi-point tunnels, right? So give me 1 second. All right. So what I've done next is I've gone and removed the tunnels which we had created, right? So we'll basically look into our next option, which is the 624, right? And look into how to get this running. Okay. So pretty much the first step is pretty much same. So let's go, because I've already deleted the tunnel. Let's go with R1 and I'm gonna say interface tunnel 0. Okay. So interface tunnel 0, cool. So I've created a tunnel. Let's look at the IPv4 side of things a bit, right? On R1, do show IP interface brief. What do we have? So we've got this Ethernet 0/2, which is basically the interface of R1 facing towards the core of the network, towards R2, right? And that will be generally my tunnel source, correct? Whenever I create a tunnel source earlier, I created, I used loopback 0 last time. But this time let's use probably the physical interface, not the logical interface. So we'll use Ethernet 0/2, right? Just let's check if routing is working perfectly. Do show IP route. Right, there you go. So all these networks are present as part of the route. So that's good. Okay. Anyway, so we are on interface tunnel 0. So what do we do now? First thing is, let's put in a IPv6 address, right? The tunnel should have a IPv6 address, correct? Only then, you can do some routing on top of it, or, basically that's exactly what we did earlier. But for 624, this is where it changes a bit, right? In GRE and in IPv6 IP, we directly went and put a IPv6 network address on both the sides of the tunnel and it came up. But in our case here, in case of 624, the first 16 bits, right, or basically, yeah, the first 16 bits is supposed to be 2002, right? I think you can basically use to any of your global address as well, basically 2001 and stuff like that, but it is recommended to use, I guess, to use 2002, right? That's fixed. The next 32 bits are very interesting. What are the next 32 bits? The next 32 bits are basically nothing but this 32-bit IP address of the tunnel source. In our case, we are planning to use Ethernet 0/2, so it is this one. So 173, right, if you convert to your binary, it's going to be AD, okay? And then you've got 1, so basically the next 8 bits is basically going to be 0, 1, right? So you're basically mapping this as is, right? Then what? You have 12. 12 is nothing but C, right? So you can put either 0C or C, right? Because leading zeros don't have any value in IPv6. What is the last one remaining? It is 1, right? So we'll write the 1 over here. There you go. So the first 16 bits was 2002, that's fixed. Whereas the next 32 bits are basically derived from where? From the tunnel source IPv4 address. And then you have the host part kind of, which can be 1 on one side and 4 on the other side, right? It can be anything. It doesn't have to be 1. I'm just using 1. So that's how you define the IPv6 address, right? That's why the whole name, right? 624. So you're embedding this IPv4 address inside this IPv6 so that the router can figure it out for itself with what to build the tunnel, right? And this is basically ties back to what I was studying earlier. These are not point-to-point tunnels. These are multi-point tunnels, right? So I'm going to say tunnel source, and what exactly you need to use the exact tunnel source which you used just now. So in our case, this guy, tunnel source Ethernet 0/2. Then you have tunnel mode, right? Tunnel mode. What is the mode? So I would say 624 tunnel is a flavor of the previous one, which is IPv6 IP. So I can use tunnel mode IPv6 IP, right? And inside that it is, if you put a question mark, you'll get two options, right? This is 624 is what we are exploring now. Got it? So the same thing, let's do it on the other side. That's R4. So interface tunnel 0, IPv6 address, and what is the v6 address? Same thing, 2002, but only change here is, okay, we don't have the address yet, so let's grab that. So do show IP interface brief, right? This is the one. So we'll say IPv6 address 2002. What is 173? It's going to be same thing. 80. What is 1? It's going to be 01, right? Colon 34. 34 is nothing but in binary it will be 22, 22, and then you have last is basically 4, right? So that's basically going to be, give me 1 second. Yeah, so the last one, what is the last one? It's going to be 4, so that will be 04 over here. Okay, and so that's basically it, I guess. Okay, we'll put colon 4 on this side, /64, basically the prefix. Okay, cool. So we did that. Now what is the problem here? Do you see a very obvious problem, right? The obvious problem is, let's look at the addresses here. The addresses which formed here on one side was nothing but, okay, we probably missed out. Did we already put the source interface? We did not. Okay, let's do that. Let's say tunnel source is Ethernet 0/1. Okay, and tunnel mode is nothing but IPv6 v6 IP and 624. Okay, that's good. Cool. But what is the obvious problem here, right? Look at this address. Look at this address, one side of the tunnel and the other side is this one. We are telling here, what we are telling here is we are putting /64, which means we are calling the first 64 bits at the network part. But if you compare the first 64 bits, right, this is 16, 32, 48, and the last 4 are basically zeros. But if you take that and if you compare here, right, it's different, right? So that's really not going to work out, right? So when you use a /64 on either of the side of the interface, you mean that they are in the same network. So if you're using this, then technically you should use the same thing on the other side as well. So if that is not maintained, or if that rule is not maintained, then it's going to create trouble when you have to probably run a dynamic routing protocol, right? If they're in the same network, then you just need to enable the routing protocol under that interface. You can just say what IPv6 EIGRP 100 like we did earlier, or we can say what OSPF, we can enable OSPF or ISATAP, whichever routing protocol. We can just go to the interface and enable it, and the interface would basically appear with the neighboring other side of the tunnel. But this is really not going to work out because this IPv4 address which is embedded inside this v6, they decided to embed it in the network part of it, and as a result, what is happening on either side of the tunnel, we are ending up with different addresses, right? So this is really not that much used in the actual production network, right? In fact, I don't think anyone would even use it. I'm just calling it out here because it's a technically way of doing it, but yeah. Now what will be the fix for this? The fix is go on R1, right, and put a static route. So I'm going to say IPv6 route, right, and what will be the static route? I mean, out of these both addresses which we just now created, only the 2002 is the common part. So what I'm going to do is I'm going to say IP route. I'm going to put a static route for that part, right, /16 I'll have to use. And I'm going to say any traffic which is destined for this 2002 network, send it on tunnel 0. The same thing I will have to put it on the other side as well. So let's come quickly put it here, right? So that's one thing, right? Second thing is, so that's one of the problem which we solved. The second is, since we really can't do dynamic routing now, right? If they both were in the same network, then we could have done dynamic routing, right? So we'll have to resort to some kind of a static routing. I mean, technically there are ways to make dynamic routing work You can also run probably BGP, which is the simplest, but we'll not get into all of that. We just want these both to work for now, the tunnel to come up. So what we can do is we can resort to static routing. So what I'm going to do is I'm going to say IPv6 route, right? What will be the route to what do I want to reach? At the end of the day, from my R1, I want to reach to this switch 2, the network behind it, right? So I'm going to say R1 route, and what is switch 2? Let's come to switch 2, and here we should have the, okay, probably I've got, let's do that. Show IPv6 interface brief, right? And there you go, the switch 2. So this is the network which we have, right? It's basically 2001 DB8 100:8:8. So this is the /64 network. This is the /128, right? This is basically like a normal loopback. And loopback 1 is basically a network which is it's simulating actually a subnet, right? Since we don't really have any other network behind this switch 2, we are simulating a network using this loopback 1, and this is /64. Okay, so we will basically need to grab this one. Let's go to switch 1, router 1, and I'm saying IPv6 route to this network. The mask is 64. So to get to that network, let's use tunnel 0. But that will not be enough. We should also give the next hop. What is the next hop? The next hop is the other end of the tunnel. What is the other end of the tunnel? We have it over here, right? This address. So we'll have to grab that and give it here. Okay, that did not work for some reason. Okay, I missed a colon here. See, that's bad. Let's put the colon. Okay, there you go, that worked. And obviously we will also need to, did we already enable IPv6 on this one? If we have not, let's do that. What I mean to say is, let's actually wait. Let's actually do it step by step. So we have enabled the static route on one side. Let's actually go and enable the same static route on the other side, right? The only difference here is going to be, let's come here, it's going to be 7, right? Because that is switch 1. Yeah, and then we'll say /64. So that's the switch 1's network. And what will be the next hop? So the next hop will be basically this address, which is on the R1 side. Okay, I think I missed the tunnel 0 in the middle. Let's put that. Okay, there you go. That's done. Now, if you really want, what we have done is we have set up the tunnel, right? So the tunnel will be reachable, right? And I'll explain a little bit more on the tunnel, but before that, there's one more step which is remaining. What is it? So we have this IPv6 running here, right? We have the IPv6 EIGRP running here. We have it running here, but we have static route running on the tunnel. We don't have EIGRP on the tunnel. We have the static route on the tunnel. So it's better to redistribute this static route inside this EIGRP, right? So that the EIGRP will be able to, the traffic, you know, from the switch 1 will be able to traverse the tunnel. So let's do that. So let's get to probably router 1, and we'll say IPv6 router EIGRP 100, right? So inside that we will say redistribute and static, right? We'll redistribute static with a metric of, I don't know, 1500, and the EIGRP you will have to give the 4 ones, right? That's how you do it. The same thing will need to go on the other side as well. So let's go to R4 and we will say redistribute. We'll say static with a metric of, I don't know, 1500, 11111, right? Cool. There you go. That's what we did. So now let's quickly analyze what we did, right? Let's look at one side at least to analyze. So let's look at the configuration of tunnel. Interface tunnel 0. Okay, so this is what we did. But it's really fun actually. I mean, if you really understand this, right, it's really useful. So we have the tunnel, we have put in an IPv6 address on it, right? And we have also put the tunnel source as Ethernet 0/2. This Ethernet 0/2 just has IPv4 address. So we took its IPv4 address and we embedded in these 32 bits. And we explicitly told the tunnel mode as 6 to 4. So what will this router do is, when it forms the tunnel, right, the tunnel has to be formed over IPv4 itself, because we really don't have IPv6 in this yellow region. We just have IPv4. So the tunnel needs to be formed over IPv4. But then I know the tunnel source address, but I don't have the tunnel destination, right? It's not a point-to-point tunnel like we did earlier. So it doesn't have tunnel destination. So how will it form the tunnel? So that's a very interesting problem, right? So what the router does is it picks it basically extracts the tunnel destination from this part, right? So it extracts it from here. So as a result, right, this will basically resolve to, it will basically resolve, and give me 1 second. Okay, my bad, my mouse stopped working for a minute. All right, so where will be? So we have mentioned the tunnel source, right, which is Ethernet 0/2. And we have also given the IPv6 address. And inside this IPv6 address, we have embedded this particular 32 bits, which is nothing but the IPv4 address of the Ethernet 0/2. So this router, when it forms the tunnel, it notes the source, and for the destination, what it will do is on the other side, when you run the same thing, do show interface tunnel 0, right? So what it is going to do is, so it's going to, my bad. Yeah, so it's basically going to look at this 32 bits on the other side, and from here it is going to extract, right? So this will be the tunnel destination for this particular ISATAP tunnel, right? So from this, it's going to grab the IPv4 address, which is 173.134.1, and from the underlay, using the underlay, which is the OSPF, which is running right in the center section or the center box, which I've been showing you, it will form the tunnel, right? So that's exactly what is going to happen. So let's actually give this a run. All right, so I have the capture ready, which means on switch 1, let's try to ping the other side, which is switch 2, right? And we have basically put the static route for this network, right, which is loopback 1. So I've just pasted it here, and let's try to do a ping. There you go, it works. So let's look at the packet capture here to understand how it really worked. You can see here, so this is the packet which I've highlighted here. You can see we have the V6 ICMP part inside it, and we have the V6 header as well. It's basically nothing but the V6 header, basically switch 1 and switch 2, right, source and destination. And you can see the IPv4 header, right, and inside that it has correctly picked the source address of the R1, right, the tunnel source, and it has also picked the tunnel destination correctly, right? And it has picked this because we have explicitly mentioned it inside, we have kind of embedded inside the 624's IPv6 address, right? I showed you how to embed it, right? Convert that decimal to binary and embed it. So because of that, because we have hidden that IPv4 address inside IPv6, the router is able to pick on it, and it is able to use that to create this tunnel. So once it is creating this tunnel, it is able to send any IPv6 data inside the tunnel, right? So obviously, I mean, the advantages is that, let me just close this because I don't want it. Okay, so the advantage is that I would say in the configuration, if you see, we did not really have to put the tunnel destination anymore because it is a multi-point tunnel. It is no longer a point-to-point tunnel. But on the other side, the disadvantage obviously of this is that we had to we no longer can put dynamic routing easily. I mean, we can do it. It's a bit tricky, but it's not easy to set up a dynamic routing between R1 and R4. We had to resort to static routes. So if you have a lot of sites, right, say hundreds of sites, then it might be difficult to set up so many tunnels, right? Or basically set up so many static routes, my bad, right? So you could still do it probably using BGP, but yeah, it's not a very, very favorable solution. The main problem here was that when we set up the tunnel on either side of the tunnel, the IP addresses were not in the same subnet. Reason? Because the router was creating that IPv6 address, or we had to create that IPv6 address by taking the IPv4 address, and we had to hide it inside the network portion of the IPv6 address. As a result, the address which we ended up on R1 and R4 were completely different, so they were not in the same subnet. So that is the problem which we are solving using ISATAP tunnels, which is the very next type. All right. So for the ISATAP tunnels, right, that's the last one which we'll discuss, right, this one, ISATAP tunnels. Like I said, the problem statement is pretty simple. We want to have something like 6 to 4 tunnels, but at the same time, we should be able to easily use dynamic routing instead of having to do always static routing, right? So that's the problem which we are trying to solve. So let's get to it, right? I've disabled the tunnel. I've removed the tunnel from the previous experiment. So let's go and enable the tunnel again. So tunnel 0. And what will be the tunnel source? The tunnel source will be basically Ethernet 0/2. Nothing difference over there, right? We are still using the physical interface. What will be the tunnel mode, right? So let's say tunnel mode is going to be same thing, IPv6 IP. If you put a question mark, you'll get the ISATAP tunnel. So that's the new tunnel, right? And the only difference here is what happens in the next command. So we'll say IPv6 address, right? And we can now use the network portion from one of our internal addresses. We can say 2001:db8 say 100 say 200, right? We'll use this as one of our internal subnets, right? And it is going to be a /64 prefix, right? And then I can enable UI64. So as soon as I do this, the funny thing is it will create a new address for this tunnel, for the tunnel IP address, right? And what is that address? We can have a quick look. We can do show IPv6 interface. Which interface? Tunnel 0. There you go. So it has created that address. See, it has created this link local address, and then this is going to be the global unicast address as well. But here, if you observe carefully, you see that FE80 basically means that it's a link local address. 5EFE, this is basically a standard, 16 bits, which is always, this is fixed, right? They have decided that whoever designed this protocol, basically they designed that this will always be this particular 16 bits. But the next few bits, right, that is where everything changes. Right, that's where all the magic happens. So AD01C01, right? Can you relate to what we did earlier? This is nothing but the IPv4 address, isn't it? Do show IP interface brief. Right? This is nothing but this one, 173.112.1. Right? So that is basically nothing but AD01C01. So main difference here is in ISATAP, what they did was, instead of taking this and embedding it somewhere in the network portion, they put it at the last, like basically like a UI64 kind of a thing, right? So as a result, you can see from the link local, the global address is derived, and this part has basically gone at the end over here, right? So that's pretty nice, and because of that, now I can peacefully kind of like I can basically use the same /64, or basically this will be the same network on either side, right, on either side of the tunnel, right? So that's the main difference. In ISATAP, they picked this EUI part and they added it at the end, unlike in case of 624 where they added it at the starting. And because they added it at the starting, the network portion of the address changed, and as a result we ended up with different addresses on either side of the tunnel. Now because of this, so that is mainly on one side, right? We can actually see this live happening. So let me show that. So let's go to interface tunnel 0, and on this one let's put IPv6 address, right? And what is the address? 2001, same thing, the db8, whatever we used on the other side, 100:200 and :/64, and I'm gonna say UI64. Right? Now quickly let's do show IPv6 interface brief, right? So though I have put this command, right, actually I have put UI64, which means we are telling the router to figure out the host part on its own, right? So it picked up the host part, but from where? Using its MAC address. That is how normally it works, right? So the UI64, it's kind of picked from the MAC address, which is fine as of now. But as soon as I enable the rest of the command, which is basically if I put tunnel mode IPv6 IP, and if I change this to ISATAP, and once I put the tunnel source, right, the tunnel source here is basically what I've forgotten. I think it is Ethernet 0/1. Yeah, it's Ethernet 0/1, right? So the tunnel source, as soon as I put this tunnel source, right, let's observe what changes we see. Let's come here, see the difference, right? This was the previous address, see the current address. So as soon as I put the tunnel source Ethernet 0/1, and because this interface or this tunnel is a ISATAP, IPv6 ISATAP tunnel, what it did was, instead of the MAC address at the end, right, it picked the 32-bit from the IPv4 address. It picked the 32-bit from the Ethernet 0/1, right? Basically, this is nothing but mapping 2. So if I do show IP interface brief, right, you can see 173.1.34.4. So basically, this is AD012204 is nothing but this, right? So as soon as I enable that ISATAP, it changed from the normal EUI64 to this 32-bit. Cool. So that's mainly what happened, right? And the cool thing is, if you see here the address, the network part will remain the same. As a result, it's very easy to run some kind of a dynamic routing protocol, right? First, for starters, we can just run the static routing like we did earlier. So we can run the static routing. I can say something like IPv6 route. That's I'm on R1 now, right? So IPv6, actually, let's come out. I'm gonna say IPv6 route. What is the network? What is the network which we are interested? So the other side, right, on switch 2, what is the network? Let's go top. So that's the network. So let's grab this guy. Let's come on R1. I'm gonna say :/64 use tunnel 0, right? And what will be the next hop? The next hop will be the address on the R4, which is this guy. Let's grab the whole thing, right? I'm gonna put it here. So that's on R1. On R4, it's gonna be what? It's going to be IPv6 route, and we'll have to get the network from switch 1. The network is nothing but, what's the network? Let's scroll top a bit. Yeah, there we go. That's the network. So I'm going to grab that. Let's go to R4. I'm going to put that /64 tunnel 0, and what's the next hop? The next hop is basically R1, right? Because we are putting static route. This is how you create static routes. Correct? And on R1, what is the next hop? This is the one, which again, generated by the router for us. So I'm gonna put that. Okay. So once I do that, I should technically have connectivity like we had earlier. So I can just, where is my switch 1? Yeah, there we go. So I can just do the ping like we did earlier. So we can grab that, ping, and there you go. Works. I can do trace if you want, just to see the hops. There you go, right? So it went to the tunnel. This is the tunnel source. This is the tunnel destination. So it went on the tunnel, and once it exited the tunnel, it got decapsulated and it was sent to the actual destination. Right? Now the same thing what we can do is, we can do, instead of doing static routing, we can do what? Dynamic routing. So we'll take the previous command and we'll remove it. We'll remove the static route which we put in earlier. So let's say no on this one. Let's do the same thing on R4 as well. So I'm gonna say a no on this one as well. Instead, let's come to R1 and I'm gonna say so we'll say IPv6 router. So I'm gonna run EIGRP now. Router EIGRP probably 100. Okay. What's the neighbor? I can use a link local address. I don't really have to use global address, right? So the link local address of which will be on the other side. So I'll have to come to R4 and grab this link local address of the tunnel. Okay. So tunnel, but the main problem here is the neighbor command. I will have to explicitly put which, with whom do I want to form the neighborship with. I mean, I can run dynamic routing easily, but I can't really just go about enabling it under the interface, right? Like you normally do when you enable dynamic routing. Yeah, I can't I can't blindly come and enable it under the interface because it's a tunnel, right? And for a tunnel, one of the most important thing is you need to, for the tunnel connection to be up, right? We need to tell what is there on the other side, right? I basically define what is tunnel source. That basically goes into the configuration, but there is no tunnel destination because these are all dynamic multi-point tunnels. So there should be some kind of a mechanism to tell with whom do I need to set up the tunnel, right? With whom do I need to set up the neighborship, right? So I can't really do my regular, enabling routing under an interface. Rather, I have to use the neighbor command. Okay. And why are we using the neighbor command? Because we are indirectly telling, right, using this part, using this, the last 32-bit, we are indirectly telling the tunnel with whom he has to go and form the neighborship, or right. So this is kind of hidden here, right? So the IPv4 part is hidden. So when you put this information, the router will be able to set up that tunnel, will be able to set up the tunnel with the other side, with the correct IPv4 address. Otherwise, if you don't provide this information, we are indirectly telling the router to go and form tunnels with all the, IPv4 network, right? The whole complete, IPv4 network. That is technically not possible, right? So we need to explicitly tell with whom I need to peer with, and we do that by using this trick, right? By using the neighbor command and providing it in this part. So that the router can extract from that, right? So that's important. So it does bring the flexibility of running. So let's do that, right? So so I've enabled EIGRP. Let's go to tunnel 0, and I'll have to do IPv6 EIGRP 100, right? And on the other side as well, that's on R1. So on the other side, which is R4, I will have to do the same thing, which is nothing but IPv6 router EIGRP 100, and inside that we'll say neighbor. But what will be the address here? We'll have to grab it from here. Where do we get it from? Okay, over here, right? Let's grab that. So let's come here and we'll say tunnel 0, right? Why is this important? Because AD01C01, this is important, right? By providing this, we are telling the tunnel, we are telling what IPv4 address on the other side you have to form the IPv4 tunnel, right? Only over the IPv4 tunnel we can then send the IPv6 data on it. Okay, so that is important. Let's do interface tunnel 0, and we'll say IPv6 EIGRP 100. Okay, now there you go, the tunnel is up, correct? So without that it would have not worked, right? And now that we have the dynamic routing set up, we should still be able to do this, right? We should be able to ping and or do a trace as well, right? Let me grab the captures. Give me 1 second. There you go. So I've got the captures here. I think it should be somewhere here. Yeah, there you go. So that's the capture. I'm capturing it again at the same place, Ethernet 0/2, and you can see the packets flowing around, right? Let's pick probably one of the EIGRP packet. You can see you have the EIGRP data, and then you have the EIGRP, you have the IPv6 address, but then you see it is able to create this. We technically, if you look at the configuration, right, if you come down here, if you come to my R1, if you do show run interface tunnel 0, right, if you look here, we provided the tunnel source, but nowhere we provided the tunnel destination, right? In that case, how is it able to form the tunnel? How is it able to understand what is the destination IP I have to use, right? The reason is because of that. Because we have set up an ISATAP tunnel, it is able to figure out, right, from the IPv6 address on the other side, it is able to figure out what is the IPv4 address I have to form the tunnel with. Same thing with, if you look at the EIGRP section, do show run section EIGRP, right? You can see here, nowhere we provided, so nowhere we have provided, the tunnel destination, right? We are telling that form this neighborship over tunnel 0, right? Form it with this one, with this IPv6 address, right? And the reason is we have to put in this neighbor command, because otherwise just enabling IPv6 under this tunnel will not do the work for us, because we are indirectly telling, it's a logical interface, right? We are indirectly telling, go and form tunnels with everyone out there, right? That's technically not possible, right? So that's why we need to put the neighbor command, and we need to put in the link local address, because the routing process can figure out with whom I have to, you know, form that particular tunnel, or basically the ISATAP neighborship with, right? So that's important. Okay, so and then we can do a quick ping here, or trace, whatever, right? Ping maybe, and you can see the packets flowing around here, very same as what we did. I mean, this part hasn't really changed since, you know, in all these 4 exercises which we did, right? Only the difference is in GRE. If you enable GRE, you'll basically have another 4 bytes. But if you don't have GRE, which is the IPv6 IP tunnels, in that case you don't have the extra 4 bytes, right? You will always have IPv6 inside, and you will have IPv4 as the outer header, and that's how the packet flows. Okay, so hope that was useful. You can, for more understanding of the theory part and all of that, if something is not clear, head down to this particular config guide, and you should be able to get all the information which you need, right? All the configurations which I picked are basically from here, right? It's very detailed and very nicely given. There are obviously a lot of other options which I haven't explored in this video, but go ahead and try it out. Okay, so thanks a lot for watching, guys.